wonder how they told time years ago? Well, they discovered if they took a weight and hung it from a string, the period of time it took to go to one end to the other of the swing was the same and only depended on how long the string was. It turns out it doesn't make any difference how heavy the weight is or how far you swing it. It's always the same. There's one little catch: you got friction that slows it down. I'm going to give you a little demonstration. Here we got an example of this. And if I start them swinging, notice the long string goes the slowest and this goes the fastest. And if it weren't for friction, it would continue like that, but notice all of a sudden, they all of a sudden start to get back in sync and they'll be back in the same line again. And notice the weight I have over here is different than the weight there, but that doesn't make any difference. Now you see as it slows down, it starts to get back in sync and they're all marching together. And then they go away from that. Now it gets back to a wavy snake-like. And there we are, almost where we started. Now it's very sensitive to how long that string is. And what's happening is the temperature changes. And so one string will get a little longer, because most things when they get hot get a little bit bigger. And that messes that up. Well, it's an example of why it messes it up and what can be done about it. Here we have an old clock, like this grandfather clock up here. And it's a pendulum. And the thing that keeps it in time is the little pendulum there. Now if you can zoom in there, you can see the bottom of the weight is actually little tubes of mercury. And the little tubes of mercury, as they get hot, they grow up. And as the string or pendulum stick gets hot, it grows down. But when the mercury goes up, the pendulum goes down, the center of gravity stays the same. So that's an ingenious way to take care of. The old days, they didn't have air conditioning and heaters, so the temperature in the house would go up and down, so it'd keep poorer time, and this is a way to compensate for that. Here we have examples of the old grandfather clock, and here is an ingenious thing that many museums have. They have a pendulum, and the pendulum goes all the way up to the ceiling, and the bigger the building, and some railroad stations, things like that, have this pendulum, and it swings back and forth because of friction. They have to give it a little push every swing to keep it going. But here's the interesting thing. It takes 24 hours for the Earth to go around a big circle. But the pendulum doesn't know that. It goes back and forth without spinning. And so this ingenious exhibit, every hour, these are like maybe a half hour, this thing goes back and forth and knocks over one of these little balls. And at the end of the day, all of them will be knocked down, so they have to push them all up for the next day in 24 hours. So the Earth is spinning out from under this pendulum, keeps going back and forth the same way, and this goes like that. Now, here at the Science Center, we have another big demonstration of the same thing. Push the ball all the way out. And just like this one down below, eventually they get all back in line again. Now you know everything you need to know about pendulums. Stay tuned for our next science demonstration here at the Science Center.